Okay, so this is going to be notes 3.1 under quadratics, which is algebra crash course. You want to label it at the top, you can. I'm just using this as a backdrop right now, but I can't label this, so I apologize. But this is unit 3.1 algebra crash course, okay? The primary goal with this is to go over your understanding of exponents, how they operate, and how you're going to need, and hopefully how you remember how they work, okay? I don't think we've done any practice up to this point that has involved exponential simplification other than distribution, but even then you're not distributing x. So what we're going to get into today is basically about how to do that. Next week, because I believe tomorrow we're going to practice this stuff on practice sheets, and then Thursday's a half day, so we won't have anything. But next week we will have a GCF practice, which basically we'll use this information heavily. So let's get started. The first thing is, let's talk about the basics, right? Everyone knows the breakdown for a simple exponential factor. Now, keep in mind, these is x and y are just in stand-ins. Y, of course, is our power or exponent, right? Power exponent. And x is the times, x times itself, y times. So again, hopefully you guys remember, all that's basically saying is that 4 times 3, that's basically just 4 times 4 times 4. 4 to the cube power, basically 4 of it, okay? And that would be 64, okay? If you had negative 3 up to the second, it would be negative 3 times 3. Remember that when you have a second power, now this is a common mistake that I see a lot, okay? In the calculator, when you plug it in, okay, when you put negative 3 squared in the calculator, what it ends up doing is this. It gives you negative 9. And you should be asking yourself, wait a minute, but if I square negative 3, doesn't mean I have 2 of them? You do, but the problem is the negative isn't tied to the 3. It's out in the front of it. So what really is written there is this. It is dumb. The correct way, if you want to get a positive out of that, is you have to put it in parentheses. Now you're saying the negative belongs to the 3, and now you're going to get a positive number. This is uber important because going into quadratics, we're going to have parentheses all over the place. So making sure you associate and keep things constrained. This is why at the beginning of the week, we talked about 6 divided by 2, parentheses 2 plus 1, close parenthesis. That's why we talked about it, because of this. Calculators are stupid. They don't know the difference between what we want and what we don't want. It's no different than computers are actually really smart. We just don't know how to talk to them. That's why we have languages. We have to bridge the gap somehow, but they're really intelligent. They just speak in ones and zeros. We talk in, well, consonants, basically, and vowels.
Vowels, syntax.
Should be away, Kyler. Come on. Okay.
Texas Instruments is so stupid. They have a monopoly on the market.
I've had this calculator for almost 2 decades. I'm fine with that.
I mean, yeah, they've been using the same technology for like 30 years.
Yeah. So
and they charge like $80 for one of those.
Definitely more than that. But okay, now in comparison over here, now we do have the situation where we have negative 3 times negative 3, which then gives me positive 9. Okay, so please make note of the differences there. It's super important that you understand that. Okay, that's the basics. That should be nothing new to you guys. Okay, it should be very, very, very familiar. I do apologize. Also, by the way, I know that this isn't lined up perfectly. For some reason, the backside of this came out crooked. I have no idea why. I tried. Okay, but it works for what we're trying to do. Now, let's talk about the very first one. We're going to go down, up, and back around. So we're going to do a U on this thing. Okay, product rule. Okay, so the product rule states that if I have 2 x's with exponential variables, I add the 2 variables together when multiplying the bases. Okay, so in other words, if I have 2 to the 4th, that means I've got 2 times 2 times 2 times 2 times, I'll put this in parentheses just so we can keep it together, And then we have 2 times 2 times 2 over here. That means that we have 1, 2, 3, 4, 5, 6, 7 of them total. Okay? You're counting the number of 2's, and that gives you the total exponent. Does that make sense? Okay. All right. So all you really need to look at is the base is the same. Great. Who cares? We don't. All we're doing right now is applying the product rule. We don't care what 4 to the 11th is, which is what this is going to be. All we care about is having the right exponential value up there in the exponent. Now, keep in mind, you have to have the same bases in order for you to combine them. Have to have same bases.
Like you can't combine like a 5 to the 6th with a 4 to the
Well, okay, numerically you can combine them after you do whatever power. So you have 5 to the 6th and 4 to the 2nd. Find the squares first. Find their values. So 5 to the 6th, 5 times 5 times 5 times 5 times 5 times 5 times 4 times 4, and then you multiply it all together.
Yeah.
But you can't add the exponents because they don't have the same base. They have to have the same base in order for you to add the exponents. Okay, again, this should be nothing new. Yeah, I believe you guys saw this in middle school. No, first grade. No, ninth grade. You should have seen this in ninth grade, Math 1, hopefully. It's when you guys explored exponential.
Yeah.
Okay.
You said first grade.
All right. Did I say first grade? I don't know.
Yeah, at first you said first grade, then you said ninth grade.
Well, I apologize. Okay, so next up we've got 7, and then we have 7 to the... Now, if there's nothing there, there is an implied 1. If you need to write the 1, that's fine. My first 3 years of advanced mathematics in high school, what I ended up doing was putting x to the first power. It drove my teachers insane, but it made sure I knew I have one of those x's. You not believe how many people forget about that 1 and will say, oh, x plus x6, oh, it's x to the 6th. What? No, it's x to the 7th. You forgot 1. Okay? Very common mistake. If you need to write down the 1, no different than putting the 1 in front of the -3 up here. There's nothing wrong with doing that. It just takes up extra space. As long as you understand what's going on and you can explain it to me, that's perfectly fine. Okay? So 7 to the 6, 7 to the 7 to the first, 7 to the 6th gives me 7 to the 7th. Okay? Then we have -5, -5. Again, the -5 would stay in its parenthesis. And we get 10 to the power, 2 plus 8. If there's nothing there, okay, first, that's just going to be 8 to the 4th. But I have a question for you. What is 8 to the 0? 0. Oh, I got 2 different answers now. How many people think it's 0? Show of hands. Raise your hands. Nice and all. How many think it's 1? The ones have it. Anything to the 0 power. It could be 10. It could be 100. It could be 1 billion. I don't care. If it's to a 0 power, it's 1. Doesn't matter.
So does that mean an exponent of 0 is equivalent to an exponent of 1? You get what I'm saying?
No, because if you have 7 to the first power, it's 7. 7 to the 0 power is 1. Good question. Yes, they are not equivalent to each other. 7 to the first power gives you that number. 7 to the 0 gives you 1.
Why 1?
There is a limit you will learn in, I want to say Math 3 or pre-calculus that will explain that to you. But it has to do with an approach along the y-axis, I want to say, and it's basically an estimation, but it's been proven so much at this point they're like, I think that's what it is. It's been a while, but it is basically just generally accepted that anything to 0 power is 1, and that's all you need to worry about. Yes.
So is it 8 to the 4th power? Or?
It's 8 to the 4th power, because this guy literally goes to 1. And if you need to cross him out like that, I highly encourage that. If you got x to the 0, cross it out, make it 1. That's the other crazy part. Any variable to a 0 power is 1. Y, x, z. It doesn't matter. Anything to the 0 power will give you 1, which is why when you see something to the 0 power, you should be smiling. You're like, ooh, freebie. 1. Okay? Very, very, very important. Okay?
It would just make me angry. This doesn't make sense. I'll just
To
see it and I'll just
the
get irrational.
0 power is 1. And I mean any. Well, I shortened that, but any to the 0 power. So anything to the 0 power, doesn't matter. Okay. Next one, we have x to the 3rd, x to the 90. So that means x is 93. And then we have a squared and times a to the 3rd. That's going to give me a to the 5th. Okay. And there's all our products. explained in terms of expandables. Okay. All right. Any questions so far on product rule? Again, don't worry if you're going to fall behind. This video will be up on Schoology before I leave work today, as well as a scanned version of these notes, not the ones that came with where I got this, because quite frankly, I'm annotating. Okay, so power rule. Okay, power rule on the other hand. Okay. Power rule on the other hand is the multiplication version, essentially, of our previous addition, okay? So what basically the power rule states is that if you have something to the power of another number, so 3 to the second, that's going to be 2 to the third times 2 to the second. That's basically what it's saying. And from there, I then would have 2 times 2 times 2, and I would have 2 times, oh wait, my bad. That should be a 3 there. 2 times 2 times 2. So 2 to the third, 2 to the third. You have 2/3. You have 2 of these. Okay? Yes. I said it wrong the first time.
So then where does the 2 to the 2?
That's 2 to the third. I messed up. That is 2 to the third. There. So you have 2 to the third 2 times. Does that make sense? Because you have it squared. Okay? Therefore, it would be 2 to the 7th. I mean 6th. Oh my god, my goodness gracious. I am having brain farts all over the place today. My bad. There you go. 2 to the 6th. My bad. All right, so we have 2 to the 6th. So the power rule basically states that x to the a and then to the b means x times ab, okay? So whenever you see a power to a power, you're just multiplying the two powers together. That's it. So you literally would do then 2 times 3 would be 6. 6, 2, into 0. 2 times 0 is what? 0. What's 6 to the 0? 1. Okay. X to the 4 and 8th. So what is 8 times 4 times 8? 32. All right, here's a chain one together. So we have 2 to the third, 2/3 to the third, which is going to give me 2 ninths. 2 to the 9th. Brain. 2 to the 9th times 2 to the 5th. Now we're going to add them together because now we have just 2 with the same base, but we're multiplying. And that's going to give me 2 to the 14th. And then finally, we have -3 squared to the 4th. Okay? Be careful on this one. -3 is stating that it's 2, 2. But the thing is, we just want to get these guys together. So we're going to get -3 to the 8th. If you were to numerically calculate that, you will get a positive number. Yes.
So for number 4, I thought with exponents we would multiply. Oh, that's only if it's outside the parentheses.
Yep. Ugh, allergies.
Why is that is syntax around the around number 5?
Yes. Because -3 is on its own thing and it's 2 squared, but we want to make sure it's to prevent basically parentheses within parentheses. The more parentheses you have, the more complicated something gets. So having different syntax helps. Versus this presentation.
Yeah, I've done that before.
Yeah, that doesn't look as good.
Yeah.
It just looks confusing. So having these box brackets help you understand, oh, this is inside, this is outside. A lot easier when dealing with multiple negatives and parentheses.
Especially if you're doing like college level math, which is basically when they just decide to throw a ton of Greek letters in there.
Yes, those Greek letters being stand-ins for constants.
Why?
Because that's what they chose.
Why would we use Greek letters?
Because we use the letters in the alphabet.
Why Greek? Why not Latin?
Oh God, no. We used to write all mathematics in Latin. Let's not go back to that, please. was done primarily to control the knowledge too.
That makes sense.
Yeah, only part of Newton that I disagree with. Yes.
That was a big part of why the church, for the longest time, the Catholic Church, a lot of the sermons were in Latin.
Yep. All right. So next up, all right, let's go ahead. We'll close that side down. It's done. Now we're going to talk about the zero exponent. Okay. This is what I was talking about earlier, right? Any number to the zero power equals 1. Okay? It does not matter what it is. 4 to the 0, 1. A to the 0, 1. 1,983 to the 0, it's 1. Negative 2 to the 0 is also 1. Every single time, it doesn't care. It doesn't discriminate. You get the 0 power, you get a 1, you get a 1, you get a 1, you get a 1.
Okay, Oprah.
Yes, I know. That's what I was referencing. Okay? That's like the easiest rule of them all. Now, because I know some people right now, I can get this quotient rule down here, though. The quotient rule, on the other hand, okay, we have 3 to the 7th over 3 to the 4th. This is basically what we like to call is the subtraction rule, but numerically, this is what's going on. So we have 3 7s on the top. 3 times 3 times 3 times 3. 1, 2, 3, 4, 5, 6, and 7. And then 4 on the bottom. What is effectively mathematically going on here is they're canceling out 3s, okay? So this is going to go, this is going to go, this is going to go, and this is going to go, leaving you with only 3 left over. So then you would have 3 times 3 times 3, which gives you 3 to the 3rd. That's the long way of doing it. The short way of doing it, actually those lines aren't that good. Hold on, give me another color. Pink's fine. There we go. And that's the part we're concerned with. The short way of dealing with the quotient rule is we have ax over xb and x equals a minus b, okay? So what we're basically doing is we're subtracting the exponent instead of adding or multiplying them in this case. So for this one, we'd have 10 over 12 tenths, 12 to the 10th over 12 to the 3rd, okay? So that would give us 12 to the 7th, 4 to the 8th, 4 to the 5th, 4 to the 3rd. W to the 7th, W to the 6th would be W to the 1st or just W. Okay? And finally, 7 to the 4th, 7 to the 4th gives me 7 to the 0, which just equals 1. Okay? That's it. Now, some of you may be asking yourselves, what about division? Or what about dividing exponential nomenclature? Meaning that how do I divide x to the 8th and x to the 4th so I can divide 8 by 4? You can't. There is not a rule that I know of at this particular moment that allows you to divide exponential values. It doesn't exist. Okay. There is one, however, that is a bit stranger that we are going to talk about. And this one's super important for manipulating quadratic functions and other functions later on to better suit your needs and allow you to simplify easier. It's the last rule on the list, and it's called the negative exponent rule. Okay? The negative exponent rule states the following. Okay? Negative exponent rule, x to the negative a equals 1 over xa. Okay? That's basically what it's saying. What it's saying is, if you have a negative exponent and put it in the denominator of a fraction, it becomes positive. Remember, every single numeric value in existence is over 1. No different than it has 1 in front. No different than it has 1 to its power. Okay? Every single value. So if you have an x, right? You have a 1 underneath it. You have a 1 in front of it. And you have a 1 to its power. Okay? That's the case with every single variable and number in existence. It has these implied values around it. We don't write them because it's redundant, but they're used in algebra to manipulate the equation, the function or the variable or the integer or whatever to help you. Most notably, if we look here, this x negative a can be rewritten as 1 over ax, x to the a. Sorry, 1 over xa, x to the a. Okay, because it has an invisible 1 down here. We just can't see him, right? He's just down there chilling in the basement. Okay?
Joke I can make out of that.
Please don't. Okay. So, for example, with negative 3 to the negative 3 to the negative 3, we have 1 over 3 to the third. That's literally all we're doing. We are taking this guy and putting him in the denominator and making him positive. Or make positive exp, which is basically exponent for short. Okay? So then we would have a to the 8th.
You said EXP, all I can think of is Minecraft.
Yes. Okay? If we have 2 to the negative 4th, 2 to the 6th, okay? That's a different story. Now, as always, we will add these guys together. Okay? And numerically, what we get out of it is 2 to the 2nd. We don't need to put them in the denominator because it's positive. If you get a negative exponent out of multiplying two exponents together, let's say I had negative 10 instead of negative 4, then you put it over 1 over, what would that be? 10 minus 6 is 4. 2 to the 4th. Okay? All right. And then down here, we have 9 to the negative 2 and the 4th. So we get 1 over 9 to the 8th. Because, again, these are going to be negative, which gives me 9 to the negative 8. We don't want them up above the 1 here. We want to put them down here. So then we would do that. Okay? And then we have 12 to the negative 2, 12 to the 8. And sometimes you could just rewrite this as like that, and then just pretend you're subtracting these two numbers and ignore these. So negative 2 minus 8 is going to give me 12 to the negative 10. Rewritten, 1 over 12 to the 10th. Okay? Does that make sense? Okay. And finally, if you have a negative in the denominator, guess what? You can bring them back upstairs and make it positive. Yes, I know. It's perfectly fine. So understand, you can move exponential values around all over the place as much as you want. Okay?